We're given vector A and B in component form, though notice how the z component of vector B is the variable k, and we're asked to find k so that vector A and vector B will be orthogonal or perpendicular. To solve this problem, we need to remember that if the dot product of two vectors is equal to 0, the two vectors are orthogonal or perpendicular. So in this case, we would have vector A dotted with vector B must equal 0. This will give us an equation which we can then solve for k. So now we'll find the dot product, which would be 3 times 5 plus negative 4 times 3 plus 2 times k. So once again, we'd have 3 times 5 plus negative 4 times 3 plus 2 times k, which must equal 0 if the two vectors are orthogonal. So simplifying, we have 15 plus negative 12 plus 2k equals 0. This would be positive 3 plus 2k equals 0. Now subtracting 3 on both sides, we would have 2k equals negative 3. Dividing both sides by 2 gives us k equals negative 3 halves. So if k equals negative 3 halves, the dot product is equal to 0, and therefore vector A and B would be orthogonal. Let's verify this by looking at the graph of vector A and B in space when k is equal to negative 3 halves. Here are the two vectors, and notice how in this position we can see that the two vectors are orthogonal or perpendicular because the angle between the two vectors equals 90 degrees or pi over 2 radians. But notice, if you look at this at a different angle, it's not quite as obvious. I hope you found this helpful.